Hey everyone, welcome back to another e-learning video. So hopefully you're keeping up with all your work and you're not going crazy from boredom. Today we're going to do the Boyle's Law practice problems. And if you notice here, it gives you the formula right here. And it's actually pretty easy to do once I've divided them into individual parts. So today I'm going to do numbers 1 through, I believe, number 7, and then the next day I'm going to do 7 or 8 through 11. Alright, so it says 15.35 liters of a gas is at a pressure of 198 kPa. At what pressure would the gas have a volume of 13.78 liters? Alright, so kind of just as a reminder, let's talk about what units are volume. So liters or milliliters is going to be volume. Alright, and then if we have mmHg, which stands for millimeters of mercury, kPa, torr, psi, or atm, those are all going to be pressures. Alright, so it says 15.35 capital L, which stands for liters. Alright, so 15.35 liters, that's going to be a volume. So I'm going to put that right here, 15.35 liters, is at a pressure of 198 kPa. So 198 kPa is going to be our first pressure. And some of you may ask me, well, how do you know that this one goes with this one? They're in the same sentence together, so I'm just going to assume that they go together. So that's P1 and that's V1. Alright, so for P2 it says at what pressure, so we don't know at what pressure, so the P2 is going to be our X or our unknown. Alright, at what pressure would the gas have a volume of 13.78 liters? So 13.78 liters is going to go there. So again, liters or milliliters, that's going to be a volume. I don't know if you can hear my computer again. It sounds like it's a jet plane about to take off, so just ignore it. Alright, so here's the formula that you're going to need here. P1V1 equals P2V2. And now I'm just going to plug these numbers in where they go. Alright, so it's going to be 198 times 15.35 equals X times 13.78. Alright, so again, the parentheses just mean multiplication. I could have used dots. That's pretty easy to use as well. Alright, so now I'm going to take out my calculator here, and I'm going to do 198 times 15.35, and that's going to give me 3,039.3 on the left side, and then on the right side I've just got 13.78 times x, so 13.78x. Alright, to solve this is multiplication here, 13.78 times x. I'm going to do the opposite of that, which is division. So I'm going to do divided by 13.78 to get this x by itself. And whatever I do to one side, I have to do to the other side. Alright, so now in my calculator, I'm going to do 3039.3 divided by 13.78. And that is going to give me 220. And mine says 0.5587808. I'm just going to round it to 0.56 equals x. Alright, so now the next thing we need to know is we need to know what units it is, or what units it, I guess it's not R. So anyways, so this is going to be 220.56, and since the units have to match, it's going to be kPa. So there you go, there's your answer to the first one. 220.56 kPa. And remember, if I'm going too fast with the math, or if I'm writing too fast or something, just pause the video, finish writing down the first problem, and then catch up. Alright, next one, it says, what is the volume of a gas at 0.43 atm if it had a volume of 720 milliliters at a pressure of 698 mmHg? Ooh, this is going to be a fun one. Alright, so it says, what is the volume of a gas at 0.43 atm? So we know that atm is a pressure. Alright, so I'm going to put that for P1 as 0.43 atm. But we don't know the volume that was associated with that. So I'm going to put the V1 as X. Alright, if it had a volume of 720 milliliters, so milliliters again, that's going to be your volume, so that's going to be V2, 720 ml. at a pressure of 698 mmHg. Uh-oh, I see a problem here. Remember when we were talking about using this formula? Remember we always said that the units have to match. So since they have to match, we're going to have to convert ATM into mmHg or mmHg into atmospheres. I'm just going to convert the mmHg into atmospheres because I like atmospheres better, but you can do it the other way around. Alright, so to do that, I'm going to draw the X and then draw the line like this. The unit that I just wrote here has to go on the bottom, so it's going to be mmHg here. And then the unit I want to convert it into is going to go on the top as ATM. Alright, so now you can go back to the beginning of the study guide and you can look and you can say, okay, number 3 here, fill in the blanks with the correct number. So 1 atmosphere is 760 millimeters of mercury, or mmHg. So I'm going to put a 1 with the ATM, and I'm going to put 760 with the mmHg. So now in my calculator, I'm going to do 698 times 1 divided by 760. So it's going to be 698 times 1 divided by 760. And that's going to get me 0.918. So I'm going to round to 0.92 ATM. And I'm running out of space there, but that's okay. Alright, so now I'm going to plug in these numbers into the formula up here. Alright, so I've got 0.43, which is my P1, times X, and remember the parentheses just mean multiplication, I could have used the dots, equals, remember I have to use this 0.92 over here because it's the same unit as this one, so 0.92 times 720. Alright, so now on this side I've just got 0.43x, but on the right side I'm going to have to do some multiplication, so I'm going to have to do 0.92 times 720, and that's going to give me 662.4. Alright, and now to get the x by itself, I'm going to divide both sides by this 0.43, and that's going to give me x equals, so 662.4 divided by 0.43, and that's going to give me 1,540 point, and I'm going to round it to 0.47. Alright, so now we need to know what unit should it be. So x is here as a volume. Over here it's milliliters, and remember the two units have to match, so this is going to be milliliters, or ml. So your answer here is 1,540.47 ml, or milliliters. Alright, so remember, if I'm going too fast or I'm going too slow or whatever, pause the video, take some time to fill in the blanks, and then you can hit the, resume button, that kind of thing. Alright, so for number 3 is dealing with Charles's law. Alright, so Charles's law is going to be this V1 over T1 equals V2 over T2. Alright, so it says a gas has a volume of 13.4 liters, so 13.4 liters is going to go there, at 17 degrees Celsius. Alright, so 17 degrees Celsius. But for these, you're going to have to watch out, because you have to add what to get it into Kelvin? You have to add 273. So, add 273 to degrees Celsius to get Kelvin. Alright, so now I'm going to use my calculator. 17 plus 273. That's going to give me 290. So that's easy enough. Alright, remember Kelvin doesn't have any degrees or anything. It's just the number and then Kelvin. Alright, what is the volume of the gas at standard temperature? Oh, so they'd say standard temperature. Standard temperature is 0 degrees Celsius, or 273 Kelvin. That one might have thrown you for a loop there. Alright, so it says what is the volume of the gas? So V2 is going to be X, and this T2 is going to be 0 degrees Celsius. And we're going to add 273 to 0, which is going to give us 273 Kelvin. Just like that. Alright, so now we're going to plug these numbers into this formula up here. So I'm going to do 13.4 over 290 equals X over 273. Alright, so the easiest way to solve this is to just cross multiply, like so. So I'm going to have 290x equals 273 times 13.4. And remember, the parentheses just mean multiplication. Alright, so on this side we've just got 290 times x, which is 290x. But on this side we're going to have to do a little bit of math. We're going to do 273 times 13.4. And that's going to give me 3,658.2. So 290x equals 3650.2. To get the x by itself, I'm just going to divide by 290 on both sides. And I'm going to get x is equal to, 3658.2 divided by 290. Alright, that gives me 12.61. Alright, so since I've got 12.61, I look up here and I say, okay, well the units have to match, so 12.61, it has to be liters or a capital L. So x is going to be equal to 12.61 capital L or liters. So there's your answer for that one. Alright, so I've gotten that one, and remember again, if you fall behind or you're like, wait, what, I need to go back through that and look, click the pause button, and then you can catch back up. Alright, so now I'm going to do the next one, which is on the next page. And the next one on the next page, it is still Charles's law. So you're still going to need this formula, V1 over T1 equals V2 over T2. So you're still going to need this formula here. It says, at what temperature would the volume of the gas be equal to 0.796 liters? Alright, so it says at what temperature. So this temperature is going to be X. And then this first volume that we encounter will go for V1. So 0.796 liters, or a capital L. Alright, if the gas had a volume of 1180 ml at 144 degrees Celsius. Alright, so 1180 ml is going to be our second volume. But it looks like this is liters and this is milliliters, so that does not match. So we're going to have to fix that in a second. Alright, so 144 degrees Celsius is the second temperature. But remember, this is degrees Celsius, so we're going to have to add that magic number 273 to get it into the Kelvin temperature. Alright, so I'm going to do 144 plus 273. That gives me 417 Kelvin. Alright, and now I got to deal with this 1180 milliliters. Alright, so the easiest way to convert from milliliters to liters is just divide it by 1,000. So I'm just going to put divided by 1,000, because there's 1,000 milliliters in 1 liter, because the prefix milli means 1,000. Alright, so now on my calculator, I'm just going to do 1180, or 1,180, divided by 1,000, and that's going to give me 1.18 liters. Alright, so that was pretty simple, pretty easy. Alright, so now let's just fill in the numbers up here into the formula. Alright, so V1 is going to be 0.796 over X, which equals 1.18 over, remember we have to use the Kelvin temperature, so it's going to be 417. Alright, and the easiest way to solve this is just to cross multiply. So I'm going to do 0.796 times, and remember the little parentheses just means times 417 equals X times 1.18, just like that. Alright, so now we're going to multiply on the left side. So I'm going to do 0.796 times 417. Alright, that gives me 331.932 equals, and then on this side we've just got 1.18 X. Alright, to get the X by itself, we are going to, since this is multiplication, the opposite of multiplication is division, so I'm going to divide by the 1.18 on both sides. And X is going to be equal to, so 331.932 divided by 1.18. That's going to give me 281.298, so I'm going to round that to 0.30. And now we need to know what unit should this be in. Alright, so since this is X here for the first temperature, this is Kelvin, this has to be Kelvin. So it's 281.30, and it's in Kelvin. Alright, so there's your answer. And remember, Kelvin doesn't have like degrees or anything like that. It's just Kelvin. Why, you ask me? Not really sure. But it's just got Kelvin. Alright, so there's your answer, 281.30, and that is in Kelvin. Alrighty, next one is the combined gas law. And I'm going to have to get another sheet of paper because these are kind of intense. So hold on one second and I will get a sheet of paper. Alright, so I got my sheet of paper now. I just got some blank white printer paper. You can use notebook paper or you can just follow along on the sheet. It's really up to you. So the combined gas law, here's the formula for the combined gas law. It printed kind of small, I don't know why, but it's P1 times V1 over T1 equals P2 times V2 over T2. Alright, so it says 115 milliliters of a gas is at 45.8 kPa and 57.2 degrees Celsius. Alright, so this first one, 115 ml, that is going to be a volume. So remember, ml or L equals volume. Alright, so the first V is going to be 115 ml. Alright, at 45.8 kPa. Alright, so remember mmHg, kPa, torr, atm, psi, those are all pressures. Okay, so P1 is going to be 45.8, and that's in kPa. Alright, and then finally 57.2 degrees Celsius is going to be a temperature. But remember, we got to add that magic number, that 273, to get it into Kelvin. Alright, so now on my calculator I'm going to do 57.2 plus 273. Alright, that gives me 330.2, and that's in Kelvin. Alright, what is the volume of the gas at 99.3 kPa and 112.3 degrees Celsius? Alright, so 99.3 kPa, that is going to be a pressure. So I'm going to fill that in here, 99.3 kPa. Alright, and 112.3 degrees Celsius. So degrees Celsius, that tells me that that's a temperature. So 112.3 degrees Celsius. Remember, we got to add that magic number, that 273, to get it into Kelvin. Alright, so I'm going to do 112.3 plus 273, and that's going to give me 385.3, and it's in Kelvin. Alright, and then it says, what is the volume? So this V2 is what we don't know. It's the unknown. It's our X. Alright, so I'm going to take out my other sheet of paper because there's literally no space on here to work out these problems. Alright, so here's the formula that I need. I need P1 V1 over T1 equals P2 V2 over T2. And again, if you just want to watch me work them out, or if you want to, you could probably enter some on your page and have some space for this. Alright, so here's the first pressure. It was 45.8, and then I'm going to multiply it by the first volume, the V1, which was 115, and then I'm going to put all that over the first temperature, which was 330.2. Alright, on the other side, I've got P2, which is 99.3. I'm going to multiply that times V2, which is X, all over the T2, which is 385.3. Alright, and the easiest way to solve this is just to cross multiply like so. Alright, so on the left side, I'm going to have 45.8 times 115 times 385.3 equals 330.2 times 99.3 times X. Alright, so on the left side, I'm just going to multiply all three of these numbers together in my calculator all at once. Alright, so it's going to be 45.8 times 115 times 385.3. Alright, so you've got this gigantic number, and that's perfectly fine. So I'm just going to copy this number over. So it is 2029375.1. Alright, equals, on the other side, we only have two numbers to multiply together times X. So I'm going to multiply these two numbers together, and then I'm just going to leave the x alone for right now. Alright, so on this side, I'm going to have 330.2 times 99.3. Alright, and that gives me, and I'm just going to copy this number over, 32788.86. But don't forget, we still have times x over here. Alright, so now the easiest way to get x by itself, since this is multiplication, we're just going to divide by this number, the 32788.86. And whatever we do to one side, we have to do to the other side. So on this side, we're going to do division again, 32788.86. Alright, so now in my calculator, I'm going to type in these numbers. Alright, so I've got 2029375.1 divided by 32788.86. And the answer that I get is 61.89 equals x. Alright, so now we've got 61.89 equal to x. Let's look back here on our sheet. Okay, so the x was a volume. Over here the volume is ml. And remember, these two have to match. So this one is going to have to be ml as well. So x is going to be equal to 61.89 milliliters. Okay? And then on here, I'm going to put 61.89 ml, which is milliliters. Okay? So again, if you're having trouble keeping up or something like that, and you want to, you want to pause the video, write some things down, or see where I got these numbers from, go ahead and do that, and then you can catch back up with me in a second. Alrighty, so now we've got the next problem, number 6. It says a gas has a volume of 62.65 liters at STP. So STP is standard temp and pressure. Alright, so that's what STP stands for. And STP is just an abbreviation, and it stands for 1 atmosphere, 760 millimeters of mercury, 101.3 kPa, all those different things. Alright, so the pressure that is associated with standard temperature and pressure is going to be 760 mmHg. Alright, the volume that it has here is 62.65 liters, so I'm going to put that there, 62.65 liters. And then the temperature that is associated with standard temperature and pressure is 0 degrees Celsius and 273 Kelvin. Because remember, if we just add 273 to 0, we get 273. Alright, it says, at what temperature in degrees Celsius, so this one's a fun one, would the volume of the gas be 78.31 liters at a pressure of 612 mmHg? Alright, so let's fill in what we know so far. So it says, at what temperature, so temperature, the T2 is going to be X. Would the volume of the gas be 78.31 liters? So liters, remember, is a volume, so 78.31 liters goes here. Alright, and then the pressure that's associated with that is 612.0 mmHg. Do you really need the 0.0? Not really, they just gave it for some reason. Alright, so how did I know that the mmHg were pressures? I looked up here and I said, okay, which one of these 5 are pressures? Which one of these milliliters or liters are volume? And then, of course, degrees Celsius is a temperature, but you have to convert that into Kelvin. So whenever you get this X here, this is going to be in Kelvin. But they want it in Celsius, and the easiest way to do that is just subtract 273 at the very end. Alright, so I'm going to do this on another sheet of paper. Alright, so let's write out the formula that we'll need here, which was the P1V1 over T1 equals P2V2 over T2. Alright, so now I'm just going to plug in these values into my formula here. Alright, so the first one I have is 760, and I'm going to multiply that times the 62.65 over the temperature. Remember, you have to use the Kelvin temperature, so that's going to be 273. Alright, and then on the other side, I've got 612 mmHg, which is millimeters of mercury. So 612 You don't really need the 0.0. If you want to put it, you can. I'm not going to put it just to save some space. Alright, times 78.31 over x, because we don't know what this temperature 2 is. Alright, so remember, whenever you get x here, it's going to turn out to be in Kelvin. Alright, so over here, I'm going to cross multiply here, so go here and here. So 760 times 62.65 times x is going to be equal to 273 times 612 times 78.31. Alright, so on the left side here, I'm going to take out my calculator, and I'm just going to multiply 760 times the 62.65. Alright, so that number I get is 47,614. So 47614. But don't forget, we still have this times x here, because we can't really merge those together because we have no idea what x is yet. Alright, on the other side here, we are going to multiply. We're going to do 273 times 612 times 78.31. Alright, and this is, wow, this is a gigantic number. So I'm just going to write this in. So 1308371.56. Alright, so now on the left side we've got this times x, and then over here on the right side we've got this gigantic number. So to solve for x, I'm just going to divide both sides by this 47614. Alright, 47614. Alright, so now I'm going to do 1308371.56 divided by 47614. Alright, x equals 274.79. Alright, I just rounded, so 0.787, I just rounded up to 0.79. Alright, and if we look back at the original problem here, the x was a temperature, so this number down here, the 274.79, is going to be in Kelvin. Alright, but the problem here, it didn't want Kelvin, did it? It wanted Celsius. So how can we get this number into Celsius? All you have to do is just subtract 273. Alright, so the answer is going to be 1.79 degrees Celsius. Alright, so that's relatively easy. 1.79 degrees Celsius. And trust me, there won't be any questions like this difficult on the test. I'm not going to make you do that, because this one took a while. Alright, now last one, number 7, and again it is one of the ideal gas laws. I'm sorry, the combined gas laws. So we're going to use the same formula that we used up here. Alright, so it says, what is the pressure of 1.27 liters of a gas at 288 degrees Celsius? Alright, so 1.27 liters, that's going to be a volume. 1.27 liters is going to go here. Alright, at 288 degrees Celsius, so that's going to be the temperature. But don't forget, we got to add that magic number, that 273, to it. So 288 plus 273. On my calculator, I got 561, and that's in Kelvin. Alright, so we don't know the pressure. We have no idea, so we're going to call this X. Alright, if the gas had a volume of 875 milliliters, alright, so milliliters, if you look back up here, milliliters or liters has got to be a volume. So I'm going to put the volume, the V2, 875 milliliters, at 145 kPa, so 145 kPa, which stands for kilopascals. And how did I know that was a pressure? I just looked up here and said, okay, mmHg, kPa, torr, atm, psi, those are all pressure units. Alright, and then finally, the temperature 2, the T2 is 176 degrees Celsius. So 176 degrees Celsius, I got to add that magic number, that 273. So in my calculator, 176 plus 273, that's going to give me 449, and it's in Kelvin. Alright, so before I start working on this problem, I do see one thing that it's weird or wacky or it's off. This is liters, and this is milliliters. So these two do not match. So since they don't match, we're going to have to convert one of them into the other. And the easiest way to do that is like we did up here when we had milliliters and liters, is just to divide the milliliters by 1,000 to get it into liters. So I'm just going to divide this by 1,000, and that's going to give me 0.875 liters. Alright, how did I know that there were 1,000 milliliters in 1 liter? It's basically the metric system from earlier this year. The prefix milli means like 1/1000. So if you divide it by 1,000, you can get it into liters. Alright, so now I'm going to move on to another sheet of paper because there's no room to write on here. And this is the formula that we're going to need to do this one. This is the combined gas law. So we've got P1V1 over T1 equals P2V2 over T2. Alright, the P1 is the X. It's what we don't know. We have no idea. Times the V1, which is 1.27, over the temperature, and remember it has to be in Kelvin, so I'm going to write 561. Alright, it's going to be equal to the P2, which is 145, times, we have to use the liters instead of the milliliters, because remember, these two have to match, so times 0.875, all over the temperature in Kelvin, which is 449. Alright, and now to solve this, we're just going to cross multiply again. Alright, so on the left side, it's going to be X times 1.27 times 449 equal to 561 times 145 times 0.875. Alright, so on the left side here, we just have two numbers to multiply together. So we're going to multiply the 1.27 times 449. Alright, and that gives me 570.23. Alright, so 570.23. But don't forget, we still have times X on this side because we can't combine those together. Alright, now on the other side, we are going to do 561 times 145.0, times 0.875. Alright, and then on this side we get this gigantic number, 71176.875. Alright, and now to solve this, what we're going to do is this is multiplication, and we want to get this x by itself. And to get the x by itself, we're going to do the opposite of multiplication, which is division. So we're going to divide this side by 570.23. But what we do to one side, we have to do to the other side. So now we're going to do this number, 71176.875, divided by the 570.23. And that gives me 124.82. Alright, so now looking back at the original problem, which is right here at the top, number 7, it says, what is the pressure? Alright, so this is 145 kPa, and this X is now going to be 124.82. So X equals 124.82, and it's in kPa. Alright, so there's your answer for that one. We finally solved for X. And I know this video is a little bit longer than usual. If you want to, skip through the ones that you've already done, and then just go ahead and move on to the ones that you need to figure out. If you have any questions, please send me an email or, comment on Google Classroom or something like that. Thanks for watching.